As we move on to practicing now with our e's, our e to the u functions, great time to kind of take a look at the proof for the derivative of e. And taking a second to read that and seeing each step. They actually used implicit differentiation to prove that the derivative of e to the x is e to the x. But keep in mind that when the exponent is not x, but it's another expression, that we are doing e to the u du. So read that on your own, and let's take a look here. Find some, all right. Let's see, 20, let's just look at 20. So the derivative of problem 20. So y prime is equal to, we've got a constant coefficient of 4, and it's e to the u times du. E to the u, so e to the 1 minus 2x, times the derivative of 1 minus 2x, which is just negative 2. And you can multiply that 4 and that negative 2, so y prime is equal to negative 8 e to the 1 minus 2x. On 22, let's see, we've got y prime is equal to 2 with my constant coefficient. And we're taking the derivative of e to the square root of x, so e to the u du, e to the square root of x times the derivative of square root of x. You can cancel this 2 with this 2 because they are multiplying. So the answer is going to be e to the square root of x over square root of x. Taking a look at 25, it's not an e and it's not an ln, but it is an a to the u. And I can tell because I have a base, that's not e, and I have exponents, the variables in the exponents, so exponential function with base a. So y prime is equal to, let's refresh our memory on the rule. It's actually right here. The rule was a to the u ln a du. So a to the u times ln a times du. All right. And that's pretty much all you can do because you can't multiply anything since this is 6 to the this, ln 6 that. So it's just, put them in parentheses and you're done. All right. So on this page, really 24 is just like 25, and let's look at some other ones. As we move on to page 61, I like how we have a huge summary of all the derivative forms that you have learned up to now. You've literally learned almost all of them. There's only one more that we look at, which is inverse trig functions, and I didn't circle that all, so let's try that again. Inverse trig functions. We're going to do that later on in this class. So right now, this is your toolbox. This is what you know. This is your toolbox. And the problem could be any of these or combinations of these. You do have to have all of these memorized. You have to know these by memory. You already know power rule, product rule, quotient rule by memory. You know that chain rule is not on here, but chain rule is like the power rule, d out or d stuff. You know that already. You just learned ln rule, e rule, a rule. You just learned those, and they're very easy to memorize. You've done your trig derivatives already, and you're probably almost completely memorized with them. And if you haven't, do it, because they're really quite simple to memorize. So let's take a look at some of these problems, and then I'm going to have you do some on your own, and you could check all your work in the binder. So if we look at 28, actually let's tag each one. Looking at 27, we see a power chain rule, because everything is being raised to the third power. So y prime is equal to 3 parentheses e to the x plus 3 to the second times the derivative of what's inside. Well, what's inside is e to the x plus 3. The derivative of e to the x is e to the x times 1. And that's that. We would write this as 3 e to the x parentheses to clean it up. Here we have a product rule. 1d2 plus 2d1. On number 29, it looks like we have a trig, d-trig d angle, where our angle is e to the x. Here we have an e. This is e to the u du. Here we have a regular ln of u. So the derivative is 1 over u du. Looks like we have a quotient rule right here. Another quotient rule. Another power chain, because it's all being raised to the 1/3 power. Looks like a product rule. X to the 10 is being multiplied, product rule. X to the 10 is being multiplied by 10 to the x squared. This messy little guy, number 36, it really is a trig. Oh, no, it's not a trig. No, no. This is secant squared. So we're really going to rewrite this as secant of some kind of angle in here. And we'll do that one together. I'll do that one with you. That one's going to be messy. Over here we have implicit. We have implicit differentiation here. And 38 will just be fun to do. So let's do 36, and then that'll be it. I would like you to try. I would like you to try these on your own. They are quick, so try those on your own, and let's do 36 together. So I'm going to rewrite 36 as y equals secant of ln 4x squared plus 2, all of that squared, okay, because it said secant squared. So y prime equals 2 times secant of ln of 4x squared plus 2. All that's now being raised to the first power. So we did d outer. Now we need to do d stuff. Our d stuff is a trig function with an angle that's an ln. So d stuff, it's a trig function. So we're going to do d trig, d angle. D trig. So secant of blah, blah, blah times tan of blah, blah, blah. So derivative of secant is secant tan. So secant of the angle, tan of the angle, which I'll fill in just a second, times the derivative of the angle. The angle is ln of 4x squared. So ln of 4x squared is 1 over 4x squared, oh, ln of 4x squared plus 2. 1 over 4x squared plus 2 times 8x. Wow. All right. So that's where we are at. Now we just need to simplify this. Okay? So let's simplify this. We have, let me write these ln's here. ln of 4x squared plus 2, ln of 4x squared plus 2. All right. I've got a secant of ln of 4x squared plus 2 and another secant of 4x squared plus ln of 4x squared plus 2. So we have secant squared of ln of 4x squared plus 2. We have two of those that are multiplying. That took care of this one with this one. That's multiplying by tan of ln of 4x squared plus 2. Okay, I've got a 2 and an 8x in my numerator. So 16x over 4x squared plus 2. I can simplify here. I could take out a 2 and reduce that by 2. So let's do that. Take out a 2. That makes us 2 and 1 and 8. And it looks like that is my final answer. Make sure that that's my final answer. Yes, that is my final answer. That is my derivative. That was messy, but it just was layers upon layers upon layers of the problem. So try some of these on your own. Tomorrow we will work on this in class, do some more practice, make sure we start memorizing these rules, and that is derivatives of transcendentals. Thank you.